Hello everyone, my name's Jim Webber and I'm Chief Scientist at Neo4j. Thank you so much for joining us today for our webinar on digital twin, where we're going to look at digital twins and the impact of graph data and AI in building digital twins. So I'm going to introduce things before the real speakers come on to give you their input. And I'm going to first define what we mean by digital twin. And a digital twin is something which started its life off in the manufacturing industry. It was a computer model or a simulation of some real world artifact, something expensive and potentially fragile, like a jet engine or a car suspension. And they started their lives off as a way of testing hypotheses. So in this virtualized, in this digitized model, the engineers could do all sorts of malicious and potentially dangerous and expensive things to the digital twin to see how it would react. So they could start to test hypotheses and find faults or design flaws in their systems without necessarily destructively testing an expensive real-world artifact, a physical artifact. And it turns out that digital twins in the modern era have kind of grown in their capabilities and in their utility. And no longer are we thinking of digital twin as a simulation or model of just some discrete real-world object, although that is still a valid use of digital twin. But we're now kind of thinking more broadly that we can use digital twins to create digitized models, simulations of all manner of parts of our enterprises, of our businesses, from our supply chains through to our HR systems and so on. We're able to create virtual representations of those systems and then test them or look for weaknesses and those kind of things. And as it turns out, the notion of digital twin has come at a really fortuitous time as the ascent of property graphs, graph data, and artificial intelligence has happened, have co-occurred. And so in my mind, I think I've kind of built a layered model of what it means to usefully use a digital twin. And at the bottom of this model, or leftmost in this diagram, we have this notion of a property graph, a graph data model, which I'll tell you a little bit more about in a moment. But it's a data model that's a very simple but expressive organizing principle. So it gives us a simple model of nodes connected by relationships to other nodes in order to store the fundamental data and flexibly store what ultimately will be knowledge. And the next step up of this model is that we start to treat our graphs as containing facts or knowledge, where these interlinked entities are organized according to some broader organizing principle. And this could be a hierarchy, like in a HR hierarchy or a company hierarchy, or it could be a taxonomy or an ontology. So, for example, in the world of manufacturing drugs, which is a very important topic at the moment, we may find that we're able to name, label, and reason about data by applying taxonomies and ontologies towards them. And this knowledge graph, we at Neo4j think, is a really good foundation for building the digital twin, which is itself that virtual representation of some system across its life cycle, which importantly is continuously updated from the real world twin analog into the virtual model, so that the virtual model is a timely representation of what's going on in the real world. Now, I think what makes this even more exciting is when you've got these three layers of kind of graphy data, the property graph built into a knowledge graph, and then using the knowledge graph to support a digital twin, you can then start to use all kinds of smart algorithms in our modern world, that's machine learning, artificial intelligence, to build predictive models of your digital twin. So you can get the algorithms to do the hard work of doing all the what ifs and reasoning about all kinds of opportunities and weaknesses that exist in your model that you might want to exploit. So what's graph data? I work at a graph database company, so it'd be remiss of me not to tell you that half of this world is made from graph data. And graph data is wonderful. It's extremely simple. We have some very basic idioms, as we see here, nodes and relationships. And nodes, the circles in these pictures, represent entities. And the relationships, the arrows with names in them in these pictures, represent relationships or associations. And what's lovely about this model is that we can have any cardinality of relationships between nodes, and we can have any number of different kinds of relationships between nodes. These aren't homogeneous; these are completely heterogeneous. So, for example, we can easily model networks of people following people on a social network like Twitter. But equally, we can model just as conveniently a transactional network where people have bought, returned, viewed, reviewed products all in the same graph. And in fact, in the knowledge networks, the things that we think underpin digital twin, you can start to reason about, in this case, a person who likes football, who lives in Italy, who's a fan of Juventus, who is connected via Juventus to a football player who plays football themselves. You can start to mix in all of these wonderful disparate facts about the world and make sense of them. The flip side of this coin is artificial intelligence, and the way that our AI and graph are currently being unified, again, in my mind, it's a layered model. So at the base level, we have what I think of as traditional feature-driven machine learning. You do this with kind of old school technology like relational databases, where you extract columns from your data and you treat them as features for input to your graph. To your ML model. But what I think is more interesting is when we start to think about not embedding just these discrete columns as features, but when we start to think about using the graph itself as input to the ML model. And this is enabled by a few techniques out there in the ML world. We have graph convolutional networks, or graph networks, which allow networks to be trained to understand the topology of graphs, which is something that's fundamentally important. We have techniques like graph feature extraction. So no longer are we just looking for columns in a relational database, name, age, gender, and so on, but we're actually able to extract features like centrality or page rank out of a graph, features which simply weren't there before, and push those into the machine learning model, into the pipeline. And I think what's at the top of the tree for me, if you'll excuse the slight graph pun, is that we now have algorithms for graph embeddings, where the algorithms themselves are able to encode the topology of the graph directly into the ML model, meaning that your models are even more predictive. Now, what I like about this is the idea that these things are completely complementary. The AI stuff, the graph stuff, it works hand in glove. So what I think about when I think about Neo4j and Dataiku is that this is better together. It gives you the best kind of data science. This is graph data science, graph machine learning, and the Dataiku platform gives you it where you want it, where you need it right now. And it's not just us. This isn't just these two companies here, Neo4j and Dataiku, thinking this is a good idea because we happen to have complementary systems. Not at all. We are fast followers where the intellectual leadership of artificial intelligence is heading. And in this case, globally, the intellectual leadership are the various Google companies, MIT, the Massachusetts Institute of Technology, and the University of Edinburgh, just a few hundred miles north of me here in the UK. And those folks are very keen on graphs. They're telling us that using relational inductive biases for generalized learning, being able to transfer learning in one situation into another situation, is the future. We, Neo4j, Dataiku, we are well positioned to bring this kind of deep research into enterprise technology. And we hope that today you'll learn of some of what we're doing and be able to apply that to the problems that you have. So I'll leave you with my intro just to say, look, enjoy the sessions. Got a couple of really good speakers, and we've got a panel discussion towards the end where I'll be poking them for even more answers. So enjoy the sessions. Do stay in touch with us. And at this point, I'd like to hand over to Nik Vora, who's our VP APAC at Neo4j. Nik, do you want to take control of the screen now?
Thank you, Jim. Thank you for that. Always a pleasure to learn more from you. Before I go ahead, let me start sharing my screen. Right, could you give me a quick nudge if you can see my screen?
Nik, all the way here in the UK, we now see your screen.
Beautiful. That's some knowledge graph working underneath all of this, I'm sure. Hello, everyone. Ni hao, namaste. My name is Nik Vora, and I'm one of the nodes here at Neo4j APAC, responsible for the business over here. Today, over the next 10 minutes or so, my goal is to speak about graphs and how graphs are the underpinning, along with AI, for digital twins. So many times, every one of us says everything is connected. We have heard this from our friends, from our family, the industry. Although if we look at things in discrete silos, it's often hard to see the connections that join our daily interactions with everything. But if you start analyzing how these systems are interdependent, right, from banking to transport to our housing, power, electricity, logistics, food, everything has a deep connection with each other. There are interactions that have relationships with each other, and everything we do has a dependency on something else. So this is where the fundamental underpinning of a graph is. We live in a world that can be best modeled by a graph. We see this at Neo4j across multiple different use cases. There are 5 use cases that are very close to my heart, which I'd love to share with you. FinCEN files, you must have heard over the last year or so, the International Consortium of Investigative Journalists have done the FinCEN files leak, which a lot of government officials, businessmen, entrepreneurs everywhere were part of that leak. And of the many tools that the ICIJ team used, Neo4j was a critical tool that could map out dependencies and relationships between the different stakeholders to identify where the corruption was. The corruption over here was almost industrial scale, and it required a technology like graph to understand exactly what was going on. Another use case with AstraZeneca, a leading global pharmaceutical. AstraZeneca uses a graph technology, a graph database underneath to understand how patients are tracking on the recovery, how medicines are impacting them, and hopefully try and do some preventive care with their patients and give them a nudge beforehand. A third example, and this is very close to the digital twin example that we are referring to today, is NASA. NASA was one of the very, very early pioneers for the digital twin concept coming to life. While it was found, it was brought to a model in 2002 by Michael. NASA was one of the first enterprises to invest in this technology. And using Neo4j's graph database platform, NASA was able to save 2 years and many, many $1 million in their mission to Mars. And this was helped by building a knowledge graph that modeled a digital twin for them. Another use case, which is Neo4j on cloud, is Worldline in Europe, one of the leading ticketing and travel network organizations. They use Neo4j to not just plan the network of all the rail, but also for the journey planning and ticketing system. Another very interesting use case of how knowledge graphs can impact travel and journey planning. The final one, and something we are very, very privileged to be a part of, is the COVID graph. When COVID started being a lot more intense last year, researchers globally were trying to find a solution to this. And we became part of this COVID graph project here at Neo4j, where a lot of the research over the years that was connected to each other was modeled as a knowledge graph. And then researchers are now able to use this information to come up with vaccines and other precautions a lot faster. And this is, again, we are very blessed to be in this situation where we are able to help out in this small capacity. If you turn to academia, the AI research papers featuring graph and graph-related technologies are growing up. Over the last 10 years, we have seen an exponential growth in research papers featuring graph. There are more than 200,000 downloads, more than 72,000 meetups. Neo4j is now in the top 20 databases across categories. And just if you look at the graph database category, it's the fastest growing in popularity on DB engines. Let's come to the topic of hand of digital twins. So what's a digital twin? As Jim mentioned earlier, it's really a representation. It's the mind of a machine. It's a representation of a physical artifact into a digital form, so that things that might be expensive, hazardous, or difficult or time-taking to do in the real world, you could do that at a much lower cost and risk online. So if digital twin is the answer, my point is, what's the why and the how? If that's the answer, why do you want to do it and how do you get to it? One example from our customer base is Caterpillar, a Fortune 100 heavy equipment manufacturer in the US and across the globe. They have more than 27 million warranty and service documents that they need to parse every year. Their business problem was they wanted to improve the maintenance predictability. They needed to create a knowledge graph, understanding all these documents, maintenance orders, what went wrong in the past. And they wanted to use AI and graph together to understand how can they improve their equipment value and lifespan for their customers. What they did was they created a knowledge graph through natural language processing on Neo4j for decades and decades of historical service documents, created a common ontology for complaints, symptoms, parts, gave this in the hands of the engineers and the customer satisfaction folks so that the lifespan and the equipment value goes up. This is a small example of an early stage digital twin idea, but this could be replicated at much, much larger scales. We spoke about how NASA used this to cut short their mission to Mars by 2 years. Mercedes, a very popular F1 team, dominant over the last 6 to 7 years, and dominant by far, has been using digital twin as one of their secret sauces on why they're so ahead. If you're familiar with an F1 race, there are millions and millions of permutations that can go in every race, every circuit, every track, the driver, the individual components, and all of these come together as a configuration for that particular day. And different races needs different configurations. The time to respond is not very high, and you need to switch your configurations every week. And that is where, again, a technology like digital twin can help you give the competitive advantage. There are a lot of business outcomes that we can drive from this, but what's interesting is how do you get to it? Again, as Jim mentioned earlier, knowledge graph is a kind of application built on a property graph database, and knowledge graph is the underpinning for a successful digital twin initiative. Why is knowledge graph so important? In my opinion, we look at silos a lot often. We have data lakes and data warehouses and all kinds of relational databases, which has consumer, product, all sorts of data. How are we connecting all that information to build a knowledge repository that can help us in real time to understand how these data points are connected, help us leverage historical information, help us get similar information and build into inferences and analytics that can help us going ahead. Knowledge graphs can come in very, very different shape and forms. A very simple one would be an organization. If an organization wanted a digital twin to analyze the impact by the loss of one person, you could just model that and say, what would happen if I lose this person to a competition? And then you could see who else might be impacted by the decision, who else might follow that leader into the other organization. That would show you a business continuity risk. A very simple example of an enterprise using a digital twin concept. On the security and the cybersecurity side, you could use this in identity and access. You could look at who has access to what, and if a particular person or employee was to be compromised, if the laptop or devices were to be compromised, what else would be at risk? So if you wanted to detail those scenarios out and plan for unplanned scenarios, knowledge graph on security would be the way to go. And within network, IT operations, uptime is key. Dependencies, one of the larger banks within APAC is using us to create a dependency model of where every application is, what server is it hosted on, and who has access to that. And they're trying to model what happens if a particular server goes down for maintenance or for other reasons, what end user applications will be impacted. That's, again, a very good example of how you could use a digital twin built on a knowledge graph to secure your IT operations. Why should you consider Neo4j? We spoke about how graphs, in particular knowledge graphs, are the underpinning for a digital twin. Neo4j is the creator of the property graph model and the creator of the Cypher language, which are both at the core of the GQL ISO project. We have the largest dedicated investment in graphs. 20 of the top 25 financial firms, 7 of the top 10 retail, and 7 of the top 10 software firms are using Neo4j in production for their enterprise workloads. We have thousands of customers globally. We have offices in Stockholm, Silicon Valley, London, which is where Jim is from, Munich, Paris, Malmo, and now in Singapore as well. And the beauty is we are client to cloud. You could use us on your desktop, your laptop. You could use this on-prem, hybrid, private cloud, multi-cloud, or completely database as a service with Neo4j Aura. So we are very strong across industries. We are very strong across your choice of infrastructure development, deployment, and we are very strong in our R&D. Over the last 1 year, we have increased our ability to serve you from APAC. We now have presence, we have team members and significant presence in Melbourne, Sydney, Beijing, Shenzhen, Shanghai, Singapore, Mumbai, and Kuala Lumpur. We are increasing this presence as we speak, and we look forward to hearing from you. If you have anything, feel free to write to us at apac@neo4j.com. I'm looking forward to doing amazing stuff together. And while we are doing amazing stuff together, allow me to introduce Richard Jones, who's the Vice President for APAC at Dataiku, a very good friend and a partner at Dataiku, and we look forward to hearing from you. Over to you, Richard.
Thanks, Nick. Really appreciate the introduction and being invited to the stage here to discuss digital twin. Let me share my screen, and again, I will follow suit. Do let me know when you can see the screen.
We see your screen, Richard.
Fantastic. Okay, so when I was first approached about digital twin, I kind of first off had a bit of a virtual lens of looking in a mirror and seeing myself. And having a realization that there are digital footprints of everything everywhere. And in a COVID world where everything has become virtualized in such a way, from engagement to business, from being at home, not being able to engage into your offices, to understand what is this sort of path to leveraging AI in a modern world as well more effectively. It really spiked my interest and intrigue, and I started doing more research around the digital twin concept and what that might be. And for those who follow me on LinkedIn, I kind of shared the insight of it is the Minority Report, that the kind of effectiveness of digital twin engagement to the enterprise of the future. And I think hopefully I can share some lens of what I might feel that this potentiality of the digital twin engagement, the graph mapping, structuring, and the world of enterprise AI and how they do align together. So a little bit about really what we believe AI is here to do, and how Dataiku's philosophy looks at the world of AI. And we truly believe AI is about changing and transforming your organization. And in this lens, we also say it's about using all of the types of data available. And as we've seen, that data evolves over time, and new ways of engaging data is a pretty interesting concept of managing different lenses across the enterprise. And in particular, one area that I think I see huge ability of this sort of graph and digital twin lens is in risk mitigation and a new way of looking at it. But really, there's the classic three tenets that exist in the enterprise, which is the people, the infrastructure, and the processes that sit at the underpinning of your ability to transform. And how we look at achieving the transformation is to achieve scaled value. And what do we really mean by scaled value? We kind of look at of driving the agility of not one project, not 10 projects, but thousands of projects across the enterprise every year. And in and of itself, and I'll show a little graphic in a minute around this, that kind of aligns about what that might look like. And it correlates to this whole world of graph engagement and graph data as well. But the next key tenet of assuming you're able to address all of these different types of projects with all these different types of data, you need to make sure that you then have a reliable platform and the resilience of growth being embedded. And so one of the key things that it is a factor as well that we look to drive in the value context is ensuring that as you scale your business towards AI and more utilization of different types, that you build resilience and reliability, because as you become more reliant on data, you'll become more reliant on AI, and then you need to ensure all of your governance is in place. So the long-term resilience is a major focus. And then the next major component that really I like to talk around is the pinnacle piece, which is AI just AI, or is AI just part of business? And if you've democratized the utilization across it and AI is just part of your business, you're then really going to start seeing the transformation. And this is where we talk about it's the augmentation of AI in everything, every time, for everyone. And that really is the catalyst to change. Now, if we assume that this is the foundation of what we hope enterprises want to be, I'm going to share a little GIF here, and what fascinated me on this when I was just listening to both Jim and Nick and the way they were sharing about how the engagement of the relationships exists. Now we see AI at the enterprise, and this is something maybe we can talk about in the panel as well, as a relationship of use cases being built across the enterprise to add value in every facet, in every location. And so that sort of lens of the enterprise connectivity is a value driver of really the digital twin of productivity. And so that's something we can talk about. So what about Dataiku, and what is it we do? We get asked this question a lot. We're a platform provider that basically enables the different personas of the enterprise in the data journey to engage across that data journey and simplify the challenge of AI engagement. Now, whether you are a coder or whether you are a visual person who isn't a coder, being able to maximize the potential of AI is the critical question to resolve and ask. And more importantly, being able to deploy it into production. And so the ability to do that in a single platform end to end is what Dataiku brings across the enterprise. And it does it in a number of ways with the visual engagement, the ability to use auto machine learning and or hardcore machine learning, and as Jim rightly mentioned earlier, the ability to then leverage different models and ways to look at the model. And I really like Jim's analogy of how it turns into knowledge and then really down into the next level of engagement. And so Dataiku brings all of it together to enable this life cycle of data products. Back to the very first point that we spoke about, it's not about one project, it's not about one use case, it's about tens of thousands of use cases. And we have customers that have evolved into this journey over time. And GE is a long-term customer of ours. And I'm only going to highlight a couple of key points that I think that really are the key driver of unlocking value to the enterprise, and that is here that GE has thousands of people on our platform, and they're able to deploy products and data projects within minutes, not hours, into a production state and unlock the value of that deployment. And this for me is that connectedness of people to use case to output, and that reusability to accelerate the ability to deploy in that lens of that earlier graph of showing the connectiveness of use cases across the enterprise is a critical facet that GA were able to harness into. Jim also mentioned, the pharmaceuticals. There's another pharma giant that we work with as well, and again, thousands of people engaged onto the platform. But really, what's more important here for me was the 2 to 5x acceleration in the delivery of projects. So, if we look at the execution factor of bringing in digital twin in accelerating more use cases that weren't there before to be able to look at as part of a standard pipeline for AI, this is only going to unlock more activity for the client. But so Dataiku goes beyond just being a software company. We truly feel the passion of change across the globe. And we want to do that by providing value, enabling anyone to train to learn AI, anyone to be able to use and engage AI. We offer our product for free to the world to download as an individual and go and learn data science and engage in data science. We truly think that this helps modernize the globe, and in and of itself, that I think is an interesting, fascinating digital twin, which is the future of people using AI for everyday living. Who are we as an organization? Well, we've been around about 8 years. We've just gone through Series D. We're second year in a row, the leader in the Gartner Magic Quadrant for data science. And we've just released the 9th version of our platform. We now have about 600 people around the world. We've been in Asia Pacific now for about 18 months, serving customers across the business here. We have about 10% of our workforce in Asia Pacific, with offices in Australia, headquartered here in Singapore, opening in Japan, India, and Korea. And we've had our tech kind of validated, and if you look at some of the lens, what Jim was talking about, the future is of Google. Google is a capital G is an investor in Dataiku, and they sort of validated again this lens of where we're heading and the direction we're moving in. So with that, I think that's a bit about Dataiku, and that's enough about what we do. I will now come back to Jim for us to spend some time debating about the digital twin. So I will stop sharing my screen.
That's lovely. Nick, Richard, thank you both for those talks. It was lovely to hear from both of you. And I've got the really nice job now of poking you and provoking you into extracting your thoughts and opinions. So I'm going to start you off. I'm going to softball you on. Look, you both kind of enumerated a view of digital twin, but how does this really play out in the enterprise? You both work for organizations where you've done this. Could you tell the audience, in fact, tell me, because I'm genuinely fascinated, how this plays out in reality rather than just in our PowerPoint decks? So Nick, why don't you kick off first, and then Richard, jump in and eviscerate him at your volition. You might need to unmute, Nick. That's just to show the people out there that we are doing this live.
We are doing this live.
We do make these kind of mistakes.
Yeah, and if we had a digital twin advising us on this, we would have rectified this before and not in the live session. Anyways, one of the very interesting enterprise applications, right? I want to go back to the Mercedes Petronas F1 team conversation. Although we have not directly worked with them, we've worked with many banks. We've worked with half of the Mercedes Petronas brand name. We're working with the other half of it. You could guess which one. But how they're implementing the digital twin concept to their advantage is, if you look at the nuances of what happens in a race, different racetracks have different equations. There are racetracks which are very hard for overtaking. There are racetracks which are great for overtaking. There are curves. Sometimes the downforce is important. Sometimes ability to just go faster on the straights is important. Your drivers have different skill sets, And then, there's all sorts of aerodynamics coming into picture. Not to forget the tires and the temperature and the environment. Is it rainy? Is it dry? Is it snowing? And a lot of these things you can't predict before the race day, right? You can't predict before the qualification. The way the race starts is you have drivers on a grid, and then there's a race before the race day to see who goes first. And that is where Mercedes have the biggest advantage, because they put 1 million of these combinations through the digital twin before every race to find out what's their ideal configuration of the car, given the temperature forecast, given the financial forecast, given how much fuel they can carry, depending on how much their driver weighs. So all of these factors come in together before the match day, and they can do this in a simulation before deploying. And the result is they're at least a few seconds faster than any other car, right? Now, there are other things at play, but this is just one example.
So that's pretty significant. Look, and as a nerd who builds databases for a living, I get that. But Richard, how would that be exposed to like normal human beings in a business rather than nerds like me?
Yeah, indeed. Look, and so when we look at it from a standard lens, and let's say, I always like to use my wife's analogy of credit card spending and assessing how many pairs of shoes she's probably bought more than she should have, and that lens of category management, entity definition, where are you spending, and what lens of your spending correlates to the race very well. In fact, in that you have a suite of permutations. Now, I'm a business user, let's say this, in a bank, and I'm actually trying to do it at a bigger aggregate perspective of going, what is going to be the next big wave of spend on an e-commerce site, and how could I put an advertisement for my credit card to be more aligned to the best product? That's a bit more of a unrelated but correlated conversational piece. As somebody that might need to work on that in a bank, I'm going to need to access data in a different way. The way it comes to fruition is really being able to see graphical data as any other type of data, and put that into your standard way of building a decision framework or a data output that you would make decisions today, as you spoke, Jim, right at the start, in a very traditional column-based data type mindset. And the reality of what we're bringing to the table, and the reality of the evolution of things, is graph data is no different to new data, to any other data in the new world of engaging. And so this is what I see, that the ability to do that simulation, extract the value element, and from our world, do it at speed, pace, and simplified and abstracted from the complexity of what it is the digital twin of doing business execution in a new way.
I'm nodding away here. You can probably see me looking like some kind of deranged puppet. But that sings to me so much, because I have this burning ambition to be boring. And my wife would say I achieved that ambition many years ago. But the way that you put it there, graph data is no different from other data when it comes to trying to extract value. And I love that, because that sings to how uncontroversial the deployment of graphs are. Now, I mean, over here in my corner of the world, I believe graphs are phenomenally exciting, right? And you can do so many things with graph data which you can't do with normal data. But when you operationalize that graph, my ambition is that it should be so just pleasantly boring. So it's just like any other database that you're used to working with, and that just sings to me. That combination of excitement in the graphs and boredom in the data center is brilliant, and I hope that's how it plays out for most enterprise users. So let's zoom out a little bit. I guess in front of me I see two bookends in a way. Richard, you're the bookend for the AI camp, and Nick, you're the bookend for the graph camp in this sense. And both of those camps have their traditions, right? So in the AI camp, we have the statistical tradition, and in the graph data camp, we have the analytics tradition. But it's clear to me there's some blurring now, right? Otherwise, in fact, we wouldn't be on this webinar together if we didn't think that. Help me to make sense of this murky grey area in the middle. At what point does graphs overlap into AI and vice versa? Richard, do you want to have a first cut at that?
Yeah, look, I think that's a really, really interesting question, Jim, and it does touch on a very, very, I think, fascinating topic. When you look at some of the evolution of how we are trying to help analysts in the AI world, you do have, by default, you've got two camps. You have the coder camp, and they're the ones that are comfortable in this new world of coding as well, in Python, in R, in SCADA, and then you have some of the older world ones, which may be in SAS and some of these sorts of ones, which foundation in statistical, mathematical, computational lenses. And you need to have analytical visualization around that to assess how you would, as you mentioned earlier, extract feature and such like. But in the new world, where people aren't coders as well, but they need to blend it, where they don't want to know about the statistical detail behind it. They just want to click a button and they want to go, just make it happen and show me it. I think the ability to push data in and out in the way that you engage with the tool and the need is really a critical factor. I think that blending of what is analytics in that context has twofold, because you've got descriptive, which is the traditional world. And then if we get into the AI world, the prescriptive, where you're trying to predict what's happening and going to be a forward-thinking lens, I think it crosses a chasm. And if I put my lens, I'm still unsure on where that blend meets the utilization, but it is a really complex intersection across the enterprise, particularly if you think about graph as analytics as well.
Very, very good. Yeah, I have a lot of sympathy with that view. I'm not sure I can quite nail down the grey area yet. But hey, Nick, why don't you give us your opinion on where these things kind of come together?
Yeah, I think for starters, it's important to acknowledge that graph theory has been here for over 2 centuries, right? AI is not new, although if you listen to some people talk, AI was founded yesterday. But in reality, these systems have existed for a long time, right? If you strip down data science and AI right down to basics, it's feature engineering, training, and then putting into production, right? So it has to deal with how you utilize your data, how you utilize your data management, how do you utilize your training, and then how do you use that in production. And the key for me here is context. To give you an example of my personal life, if I go home and my partner is upset, and I say, I had a tiring day, you're upset. And if I don't see the context that they haven't had lunch today, right? That context is so important. And that trains me. The next time I go home, I'm now a better trained model, because I am now trained to use context and say, you're upset, and why are you upset, right? So we have been using AI and graphs and context ever since we were born, and we've been training ourselves in a very subtle way. Now this is on a machine scale, right? So for me, an example where a self-driving car is using established maps to navigate the drive, great. But the context of other similar cars on other similar routes, for some reason, are not taking a particular section of the drive, whatever might be the reason. But if you were able to use similarity, context, graph, networks, along with existing information, then in real time, you could be a lot better. So I think when you merge context with AI becomes better. It's great, it's fascinating, but you add context and your risk goes down, your confidence goes up.
I love that analogy. In fact, when you do your next startup, which is that app that tells me to behave better, I'm in. I want to be your CTO. I think we should all use that to improve. That's just lovely. So look, I think a lot of folks who are going to be watching this, I think, okay, this sounds great. I mean, both of you, you're such wonderful storytellers, and I hear this. It's very engaging. But where does the rubber meet the road, as the Americans say? How would I get going with this stuff? Because when I look on the internet, there's like a bazillion articles on AI and a gazillion articles on graphs and graph theory. So what are my good first steps? And Nick, let me throw that over to you first.
Yeah. So I go back to one of the first trainings that my parents ever gave me. I can't claim to have used it, but they said, you first see, then you think, and then you do, not in the other direction. And if you break up a digital twin, it's really those three things. You first see, you can have environmental data coming in, you could have operational data coming in, people, processes, KPIs, with the industrial internet and with a lot more options of capturing data and managing pipelines on platforms like Dataiku, it's extremely easy to capture more data. So the first part is seeing, right? Where you're creating your data models, you're creating your knowledge graph. Now, within that part, you could then use similarity and say, all right, if I'm capturing data from a particular turbo engine or a particular process, what other jet engines or processes could I get data from? And then I'm not just training on my own history, but then I'm training on history of similar objects, right? So the first layer for me is see. Then is think, which is going back to a lot more AI, going back to using context with AI on saying, how do I run my simulations? What are the inferences that are applicable? And it's not just graph, but knowledge graph would be the underpinning for using that AI. Then you connect to a platform like Dataiku and say, let me connect to Neo4j and let me do this analysis here. And that gives you the simulations and a better confidence score, right? And then the last is do. Do can either be manual, where I can go and say, next time don't do this, or for now, go do this. Or do could be an edge device, which could do it for you. The benefit of doing with an edge device is there's a feedback loop, there's a lot more precision, and then you can improve from there on and you can scale your systems. So I think for me, it's very simple: see, then think, and then do. And hopefully I do that as well.
That's perfect. So Richard, I'm going to give you the last word here. How do you think we get going with all this stuff?
Cool. So listening to some of those things, I'm a big fan of introspective perspective on how does it make my world easier, and I think every organization is made up of the same context, people, and people interact in ways and make decisions in ways that can be correlated and effectively predicted on what might be the ways they engage and do things in the future. So my lens would be, why don't you point all of your HR data to a graph database, figure out all of the chatter that is happening amongst the organization of what is going on, determine if there's going to be decisions that are going to be made, make an announcement, see how it gets impacted, and then see how you can improve the engagement of how communication flows through your enterprise. Once you've done that piece, seemingly you could probably expand it beyond that to go, let's talk about how we engage with our customers. Let's talk about how we then improve the engagement to those customers, because they're just different contexts. I would start within, experiment, figure out how you use graph data, figure out how you operationalize it fast, and then expand it to beyond the internal lens. That's where my view of starting would be.
Oh, I think that's absolutely wonderful. I think this HR use case in particular comes up a lot, and I really love the idea of understanding that your organization is a graph, not just the CIO's view, which is a hierarchy, and then being able to understand the impacts as they travel through the graph through unsupervised algorithmic analysis. It's marvelous. I'm now torn, of course, because I just pledged my allegiance to Nick's next startup. Now I think this one's a really good one, so I have to get involved in both. So look, thank you both for taking time out today. It's been wonderful to have you on this webinar and hang out a bit. I hope that when the pandemic comes towards an end, that we'll be able to do more of these things physically around the Asia Pacific region rather than doing it via electronic means. But thank you both for your talks. And I'm just going to wrap up now. A few closing remarks, just as a bookend. for our lovely folks out there. So I did notice as Nick was speaking, the examples he used were from the O'Reilly Graph Databases book, which I haven't thought about in years, which is a bit weird because I wrote it. But I thought I'd better plug that. So if you are interested in getting to do some of Nick's examples, they're freely available. If you go to the Neo4j website or graphdatabases.com, you can grab yourself a free download of that book and learn to do some of the knowledge graph examples that Nick showed. I would also give you a heads up, actually, that in the next few months, me and some colleagues at Neo4j are writing we'll be finishing a book about knowledge graphs, which includes 2 full chapters on AI and digital twins, so the stuff that we've been talking about in this webinar. So if you want to have a bit more deeper reading, rather than the talking heads that we've had here today, beautiful as the talking heads are, of course, gentlemen, then keep an eye out for that, and the team will alert you if you're interested, and you can grab a copy of that as well. So all that's left for me to say is to thank the speakers again. Thanks, Nick. Thanks, Richard, for sharing your insights today. Thank all of you for attending. I hope it's been valuable for you, and to wish you a safe and prosperous road ahead. And I hope that our paths, if you'll excuse the graph pun, will cross again very soon. Thanks, everyone. Have a super day. Bye-bye.
Thanks, Jim. Thanks, Nick. Take care.
Thank you. Take care. Bye-bye.
Cheers, guys.